The world of AI just keeps accelerating, doesn't it? It feels like we're barely getting comfortable with large language models just responding to prompts, and suddenly the whole conversation shifts again.
It absolutely does, yeah.
Right.
And what we're seeing now, and it's really highlighted across the sources you shared, is this fundamental shift away from just, reactive AI.
Right.
The focus is rapidly moving towards what people are calling agentic AI.
Agentic AI. Okay, that term keeps popping up.
Yeah.
If I'm sort of getting the core idea from these sources, we're talking about AI systems that don't just wait for a command and spit out an answer,
Exactly.
but can actually initiate tasks, plan complex sequences, coordinate with other systems, maybe even people,
Yeah.
and adapt.
Precisely. It's about systems designed to have a degree of autonomy. They operate in the real world or, the digital world to achieve objectives without constant human hand-holding. They could, say, browse the web to research something or manage complex interactions across totally different software systems. It really feels like a significant evolution in what AI can do.
Okay, let's really dig into this then. For this deep dive, we've gathered, quite a collection of articles and reports. They touch on all sides of this, the tech underneath, the real-world applications popping up, and the bigger societal and business stuff, too.
Yeah, and our goal today is basically to unpack all of that. We want to give you, the listener, a clear picture of what this agentic AI actually is. Why is it happening now? Where are we seeing the impact?
And maybe most importantly, what do businesses need to be thinking about as this whole transformation unfolds?
Exactly.
So let's start with the basics. Based on these sources, how are we defining agentic AI? And I guess what's driving it right now?
Okay, so at its heart, agentic AI systems are really characterized by their ability to initiate action. They don't just wait. They plan a series of steps to get to a goal.
Okay.
They coordinate those steps, and that could involve multiple AI subagents or even bringing in human input. And critically, they monitor their progress and can change the plan if things aren't working.
So it's very different from earlier AI, which was often more about processing one specific input in one model.
Totally. Agentic AI is about the system doing things, often across lots of different environments.
It's not just the brain, but it's got arms and legs now, digitally speaking, and the ability to interact. And the sources mentioned a specific technical piece here that sounds crucial, the Model Context Protocol, MCP.
Yes, MCP. It's definitely highlighted as a key enabler, particularly for using this stuff in businesses. It's described as a standard that lets the large language models, the brain of these agents, securely talk to external systems and APIs.
Okay, so how does that actually work?
Think of it like a secure, standardized communication layer, sort of a universal translator and a security guard rolled into one. It lets the AI agent talk to your existing databases, your CRM, your HR systems, whatever software you use.
Without needing direct access, like login details.
Exactly, without needing those sensitive credentials directly. It's a secure bridge.
That secure bridge idea really helps. It means the AI can actually use the existing tools in your business, not just, say, analyze data exported from them.
Right.
And why is all this happening now? Is it just that the LLMs got smarter?
Well, that's a huge part of it, for sure. The improved reasoning and language understanding in the latest LLMs provide that core intelligence needed. But there's another big driver, and one source makes a really compelling case for this.
Which is?
We're kind of hitting a wall with traditional software interfaces.
The complexity trap. Right. I saw that mentioned.
It's exactly that. Interfaces have just become so overloaded with features, so complex, that even simple tasks, especially in big enterprise software, mean clicking through screen after screen, navigating endless menus, filling out forms.
Yeah, tell me about it.
The source traces this evolution really nicely. We went from typing commands in a terminal.
The command line interface?
Right. Then clicking icons in GUIs, graphical user interfaces, then tapping apps on our phones. Each step was basically a translation layer, forcing us to learn the computer's way of doing things.
And now the argument is the computer's finally starting to understand our way, just using natural language.
That is the core idea of this great interface revolution the source talks about. AI becomes the new front end. It allows you to simply tell your system what you want it to do, in plain English.
The source gave some really good examples of this.
Fantastic examples.
Like the EddieBot for university admissions.
Yes. So instead of a human admissions officer having to manually sift through thousands of applications, logging into maybe 5 different systems, checking criteria one by one,
Which takes forever.
right, an officer could just ask an IdiBot something like, show me the top 50 candidates demonstrating research potential in AI and make sure they align with our diversity goals.
And the bot, how would it do that?
Well, using something like MCP to securely access student records, maybe external research databases, it could analyze transcripts, essays, recommendation letters, look for keywords related to research, cross-reference diversity metrics,
Wow.
and even suggest maybe additional candidates to balance out the criteria, all just through conversation.
Okay, that's powerful. And there was another one, the work bot for HR.
Yeah, the workbot scenario. Imagine an HR manager needs to hire, say, a senior data scientist. They just tell the workbot the requirements, the salary range they're thinking of, key responsibilities.
And the bot connects to what?
It connects, again, via MCP to the HR systems, maybe external market data APIs. And it could draft the job description, check if the salary is competitive for the market, screen incoming applications against the criteria you set.
Could it even handle scheduling?
Potentially, yes. Handle initial outreach emails or scheduling first-round interviews?
It just dramatically lowers the barrier to entry for using these really powerful, complex back-end systems. It feels like a shift from having to learn the software's specific logic
Exactly.
to the software understanding your intent.
And it's more than just following commands, remember. It's adaptive. If your request is a bit vague, the AI could ask clarifying questions. And it makes analytical insights immediately actionable. Imagine asking that workbot, okay, based on our past hiring data, which of these top candidates are most likely to stay with the company long term?
And getting an answer right there, conversationally, linked directly to the people you're considering.
Exactly. And none of this really works at scale or securely within a business without that underlying plumbing like MCP. It's what lets the natural language request translate into actual actions within the existing systems.
It sort of unlocks the functionality that's already there, but buried under clicks and menus using this natural language layer without needing a massive overhaul.
Precisely. You leverage what you have.
Okay, so we've got the definition, the tech enablers like MCP, this vision of a new interface. Where are we actually seeing these principles today, this agentic capability, or AI acting as a natural language front end? What did the sources say about real-world applications?
It's incredibly broad, actually. First off, in data access and analysis, we're seeing systems that let you query databases just using natural language.
Like typing a question instead of writing SQL.
Yeah, exactly. Tools that generate the SQL code from plain English based on models like Google's Gemini. This puts data access directly into the hands of, say, business analysts or managers who aren't SQL experts.
Democratizing data, basically.
Pretty much. And we also see things like data frame agents mention tools that let you manipulate and analyze data in tables just by talking to them. Makes data teams more efficient.
Okay, that makes sense. What about other fields? Healthcare came up, right?
Healthcare is a massive area, yes. AI is being explored for earlier disease detection. One source mentioned molecular U, tracking biomarkers to predict health risks way in advance.
Proactive health monitoring.
Right. And the idea of conversational interfaces for electronic health records, or EHRs, that could seriously streamline the administrative burden on doctors and nurses, freeing up time for actual patient care.
Yeah, anything that reduces that paperwork mountain would be huge. The legal field also seemed relevant. It's notoriously complex.
It is, and the sources mention AI assisting, particularly in areas like family law. Think about generating initial recommendations for child custody based on structured data points, or facilitating virtual mediation by suggesting possible compromise scenarios.
Or even helping sort out the division of financial assets, which can get really complicated.
Exactly. But, and this is really crucial, the sources emphasize this in these sensitive legal areas, the AI is framed strictly as an assistant.
It's not replacing the judge or the lawyer.
Absolutely not. It's about improving efficiency, maybe increasing objectivity by processing information very consistently, and potentially improving access to justice by making complex legal tasks more manageable. But the final human judgment remains paramount. The AI helps process the information, it doesn't make the decision.
Okay, that distinction is key. Education was another big one mentioned.
Yeah, there was a really powerful perspective shared from the UK Tech Secretary, Peter Kyle, who mentioned he is dyslexic.
Yeah.
He highlighted how AI could genuinely level up opportunities for dyslexic children. by transforming assessment methods, moving beyond traditional written tests, and providing highly personalized support, the kind of one-on-one attention that human educators realistically struggle to provide at scale.
That's a compelling vision. And Ohio State University.
Right. They're making AI use a requirement for all students. Their goal is for graduates to be effectively bilingual, fluent in whatever their major is, and fluent in how to apply AI within that field.
Wow, AI bilingualism.
It says a lot about what they see as essential for the future workforce, doesn't it?
It really does. What about inside businesses themselves, day-to-day operations?
Yeah, we're seeing automation of routine business tasks. Examples like AI agents taking over some of the more repetitive tasks that data analysts do, freeing them up for more strategic thinking.
Okay.
And AI being used to orchestrate quite complex workflows that might involve pulling data from one system, processing it, then pushing it to another system via APIs, coordinating across different software.
Makes sense. But on the flip side, there were also some concerns raised, particularly in creative fields.
Right. A British Film Institute report flagged real anxieties in the UK screen sector, worries about AI potentially, quote, plundering huge archives of scripts and other creative works for training data.
And the impact on jobs.
Yes, specifically concerns about threatening entry-level jobs in film, TV, games, visual effects. And we're already seeing things like AI-created advertisements becoming more common, which again raises questions about creativity, originality, and employment.
So it's that classic tension.
Yeah.
Potential for amazing new creative tools versus genuine worries about intellectual property and job displacement.
It is. We see that pattern repeat.
Yeah.
And then finally, bridging the digital and physical worlds. Robotics.
Ah, yes, connecting AI to actual movement.
Exactly. Frameworks like vBrain were mentioned, integrating multimodal AI processing images, text, maybe other sensor data for visual reasoning, and actually controlling robots in the real world.
So the robot can see and understand its environment, then act based on that understanding.
That's the goal, connecting perception to action. And explainable AI is a big research focus here too, needing to understand why the robot is deciding to do what it's doing, especially in collaborative settings.
Right, you need trust and predictability.
Mm-hmm.
Okay, so that's a huge range of applications. Now, let's switch gears slightly. For the people actually building these agentic systems, the developers, the engineers, what did the sources reveal about the practical side, the nitty-gritty challenges they're hitting?
Oh, the developer community discussions and reports definitely paint a picture of, well, it being hard work. Frameworks are popping up to help things like Crew AI, AutoGen, LangGraph, LangChain were mentioned quite a bit, especially around the Agentic AI Summit. These give you toolkits to structure these agents.
So the tools are getting there, but actually building robust systems is still tough.
Extremely tough. Developers are really grappling with performance and runtime issues, especially when you have multiple AI agents trying to work together a multi-agent system. Getting that coordination smooth and reliable is difficult.
Even with things like RAG, retrieval augmented generation.
Yeah, even with ARG, which helps models pull in external info. Getting consistent, fast, reliable operation in these complex setups is a major headache.
And I imagine debugging a system with multiple interacting agents must be a nightmare.
It absolutely is.
Yeah.
Debugging and just ensuring the whole thing can scale are huge concerns. If you have a chain of agents and one part fails or gives a weird result, tracing that back can be incredibly difficult.
And managing dependencies, too, if you rely on external AI services.
Exactly. That's another big one. If you're building an agent that calls out to, say, 3 different third-party AI APIs, what happens if one of them goes down or changes its output format slightly? Your whole workflow can break. Reliability is a constant worry.
That makes total sense. You need visibility, monitoring across that whole chain.
Precisely. There was one story about monitoring pipelines that really hit this home. It's not enough anymore to just check if your agent call technically succeeded, like did it return something?
You need more nuance.
You need a really robust monitoring and evaluation. You need to track the characteristics of the output. How long was the response? Did it vary wildly from the last time? Did it contain certain keywords you expected or didn't expect? You have to understand how the AI is performing, its behavior, not just if the API call returned a 200 OK status.
It's like that illusion of failure idea again, but for the builders. Things might look like they're working on the surface,
right.
But without that deep observability, subtle problems could be causing real issues downstream.
Exactly. And for conversational agents specifically, achieving that natural, smooth back and forth and keeping response times low, that's still a major struggle. Some developers mention grappling with 10, even 20-second delays between user input and AI response.
Which is basically unusable for a real-time chat.
For many applications, yeah. Plus, just keeping up with the terminology. The language around AI agents is evolving so fast, it adds another layer of confusion for builders trying to learn and implement this stuff.
So are there specific technical tools or maybe research directions highlighted in the sources that are trying to tackle these challenges?
Yes, definitely. The sources touch on several areas. For evaluation, there's work going beyond just simple accuracy metrics, especially for classification tasks that might happen within an agent's workflow.
Okay.
R-Rage improvements are a huge focus, trying to make that information retrieval more effective. Tools like Segment Any Text were mentioned, aimed at helping models better understand and pull information from really complex documents.
And security is obviously critical for agents acting in the world.
Absolutely. Guardrail systems are a hot topic. There was a paper discussed on something called Llama Firewall, designed to make agents more secure, prevent them from doing harmful things, or falling victim to prompt injection attacks.
No, tools to evaluate better, access information better, and keep the agents safe and on task.
That's the idea. And observability tools, things like LangFuse and TensorZero, were noted as being crucial for developers to actually monitor how their agents are behaving in detail. There's also ongoing work on document processing tools. DocTL, Dolphin were mentioned.
And on the training side, making the core models better.
Yeah, research is optimizing reinforcement learning. That's training models through trial and error with rewards. Trying to make it more efficient, maybe by focusing the RL updates on parts where the model is most uncertain, like high entropy tokens, and exploring asynchronous RL systems for faster, more scalable training.
Any specific models mentioned for these agent tasks?
A few were highlighted for specific jobs. Alibaba's Qwen3 embedding and re-ranking models were mentioned for improving text retrieval, finding the right documents. And NVIDIA's Llama Nematron Nano VL model came up for document analysis tasks, like reading text from images, OCR.
It's really clear there's this enormous amount of technical effort going into just making these agentic systems practical and robust enough for widespread use.
Okay, let's step back again. What about the broader market trends? The bigger picture implications that these sources are pointing towards?
Well, the major point that comes up repeatedly is just the sheer market traction.
Yeah.
OpenAI hitting that reported $10 billion in annual recurring revenue.
Yeah, that number jumps out.
It's cited again and again as hard evidence of the real-world utility that businesses and individuals are getting from these models right now. And that utility often stands in pretty stark contrast to some of the more academic critiques that might focus on theoretical limitations or benchmark failures.
$10 billion isn't theoretical, right? That's actual value being exchanged. What about the big tech players? How are they positioning themselves?
Microsoft's strategy seems to be shifting significantly, according to some analyses. They look very focused on making Azure the go-to platform for building and deploying AI agents.
Less about having the only best model, more about being the best place to run any agent. Kind of, yeah. Perhaps influenced by OpenAI's own strategic moves. Microsoft seems to be emphasizing providing the underlying infrastructure, cost-effective model access, the whole ecosystem. Apple, meanwhile, is clearly pushing AI hard into its devices, but some sources suggest they might still be relying on partnerships or perhaps don't yet have their own truly state-of-the-art frontier model driving everything.
Interesting dynamic. So some are building the agent brains, others are building the operating system for all agents. And alongside this, preparing the human workforce seems critical.
Absolutely. Training and readiness are huge themes across the sources. That commitment to train all civil servants in England and Wales on AI use, that's a massive signal from government.
And the Ohio State AI bilingualism requirement we talked about.
Right. And companies like Deloitte investing heavily in training their own employees, often using resources from places like NVIDIA's developer programs. It's all about ensuring staff can actually work effectively with these new AI tools and agents.
Training humans to collaborate with AI feels like it's becoming a major imperative. But that job, impact anxiety.
Yeah.
It's definitely present in the sources too, isn't it?
Oh, yeah, it is. And from different angles, you had the Klarna CEO making headlines with warnings that AI could potentially cause a recession by impacting white-collar jobs specifically.
Hmm.
And we already mentioned the BFI report and the concerns in the creative industries. These reflect very real worries about automation and its effect on employment across various sectors. The sources report these concerns prominently.
And the regulators are starting to pay closer attention.
Yes, they definitely are. Ofcom in the UK, for instance, is looking into potential limitations on how Meta uses AI in its risk assessments for content moderation and things like that.
Proactive regulation.
Trying to be.
Uh-huh.
And the UK's Financial Conduct Authority, the FCA, is doing something quite interesting, creating a supercharged sandbox in partnership with NVIDIA. The idea is to let financial firms experiment safely with advanced AI applications, but under regulatory guidance.
Nesting the waters carefully.
Exactly. And the need for security just keeps coming up, which is why that research on guardrails like Llama Firewall is seen as so important. There was also that slightly alarming mention of AI being used maliciously in scams.
The ghost students thing.
Yeah, using AI and compromised personal data to fraudulently enroll non-existent students in educational institutions to collect financial aid. It just highlights the flip side. The potential for misuse grows right alongside the capabilities.
Absolutely. Were there any national strategy angles discussed beyond the UK examples?
AI's role in national security is sort of a constant background theme in many strategic discussions globally. But one specific national initiative highlighted was India's Haratjan project.
What's that about?
It's focused on digitizing ancient Indian texts, a vast cultural heritage specifically to train sovereign AI models. The goal is to create powerful AI systems that are deeply rooted in India's diverse languages, culture, and values.
Aiming for a distinct, sort of indigenous AI capability.
That seems to be the vision. It's a fascinating example of weaving technology development together with national identity and cultural preservation.
It really is. Okay, let's circle back to that tension you mentioned near the start. The market's obvious enthusiasm for AI's utility versus the more academic or critical debate about its true intelligence or its fundamental limitations.
Yeah.
How do the sources navigate that?
It really feels like the core dynamic playing out right now. The sources generally acknowledge that while critical benchmarks and testing are valuable, they reveal limitations and sometimes maybe create an illusion of failure when models don't ace very specific, narrow, challenging tasks.
Right.
Those benchmarks don't fully capture the immense utility that real people and actual businesses are clearly finding and, paying billions of dollars for.
So the current success isn't necessarily because the AI is truly intelligent in some deep, human-like way, but because it's just incredibly useful as a tool, as an assistant.
Precisely. That seems to be the consensus from a practical standpoint. Current success is largely driven by AI's power as a force multiplier. But this also means humans need to learn how to work effectively with the AI leveraging its strengths while being aware of its specific weaknesses and limitations.
So the hype around artificial general intelligence might still be ahead of reality.
Quite possibly.
And the critiques are essential checks on that. But ignoring the practical impact and the utility that the market is clearly demonstrating right now means you're missing a huge part of the story.
Exactly. It's a really complex picture. You've got incredible ambition, serious technical hurdles, massive market adoption, and very real-world deployment challenges all happening simultaneously.
And you see that complexity reflected in some of the contrasting examples from the sources, don't you?
Totally. You've got, on one hand, the really bold vision, like DeepMind CEO, talking about AI helping humanity colonize the galaxy. And then right alongside that, you have developers wrestling with debugging complex agent interactions today. Or you see the PR stumbles, like Anthropic having to pause an AI-written blog because it wasn't quite right, or the public reaction to Duolingo replacing human contractors with AI for certain content generation tasks.
It really underscores that we're still very much figuring this out.
Yeah.
Figuring out what this technology truly is, what it can reliably do, and what it all means.
And just to add another layer of complexity, one intriguing point from the research discussed was this idea of evaluation awareness.
What's that?
Some of the most advanced models seem to be getting good at detecting when they're in a test scenario versus a real-world interaction. They might perform differently if they know they're being benchmarked.
Wow. That makes evaluating them even harder. It's almost a meta-challenge building tests that the AI can't game just because it knows it's a test.
Indeed. It adds another wrinkle to understanding their true capabilities and limitations.
So wrapping things up here, this deep dive into the sources really paints a picture of agentic AI as a significant evolution. It feels like it's fundamentally changing how we interact with computers, shifting towards natural language as the interface. And it's starting to integrate deeply into, well, almost every sector imaginable. Healthcare, law, business ops, robotics, you name it.
Yeah, it's a landscape defined by, on one hand, immense potential, driven by technical progress like MCP, ever-advancing LLMs. You've got incredibly rapid development cycles, new frameworks, new research coming out constantly.
But on the other hand,
Significant practical hurdles for the people actually building these systems, and urgent, ongoing societal and economic questions about jobs, about security, about bias, about how we regulate this incredibly powerful technology.
it's complex, it's definitely moving fast, and it feels like it's going to impact pretty much how everyone works and lives sooner or later.
Absolutely. No doubt about it.
Okay, so thinking about everything we've covered today, this idea of AI becoming agentic, of it acting on goals, and natural language becoming the primary way we interact with complex systems. Here's a thought to leave you with. Is it possible that the future of software, the future of how we use computers, will be less about learning how to use specific tools with their complicated buttons and menus, and much more about learning how to effectively collaborate with intelligent systems that understand our goals and can act on them?